This is a graph of linear and nonlinear relations. So, if we have a graph of something like cost and time, we can see from the graph that it actually makes a straight line. We know that straight lines are called linear relations. There are two variables, so two things that we're comparing. We're comparing the cost and the time. So in a linear relation, the cost is dependent on the time. So how much something costs depends on how much time it takes in this example. So another feature of linear relations are that they increase or decrease by the same amount each time. So see in this graph, the graph is going up 10 over 5, and then it's going up 20 over 10, 30 over 15. All of these have what's called a rate of change equal to 2. So they're going up by $2 every minute. So linear relations, they increase or decrease by the same amount each time. So they have this, a constant, I guess, unit rate you could relate it to. Okay, so linear relations are always straight lines. They always make straight lines, and they increase or decrease by the same amount each time. So in a graph, it's really easy to know if a relationship is linear, because if this is your graph, to know if a relationship is linear, it just has to make a straight line. For something to be nonlinear, as long as it's not a straight line, that would be nonlinear. Or I'll just do another color. This graph would be nonlinear. And do some more examples. A graph that looks like this would be nonlinear. These are all examples of nonlinear. See how they're not straight lines? Whereas if you have a straight line, it's linear. So any graph where you have a straight line, it can be this way, it could be this way. Those are all linear. Okay, you know how sometimes we create tables of values? So these are tables of values. We can tell from a table of values if it's linear or nonlinear. So remember I said this. They increase or decrease by the same amount. Let's check. In this table, time is going up by 1. See how it's going up by 1 every time? And cost is going up by 3. If we add 3, we get the next number. So these numbers are very special. We call these numbers first differences. And if these numbers are the same, like they're all 3s, that equals a linear relation. Okay, let's check another table. This is a table of time and distance. So let's look at this, the y values, the distance. What is this going up by? From 0 to 15, it goes up 15. From 15 to 18, it goes up 3. And from 18 to 26, it goes up 8. So these values, what are they called? First differences. They are not the same. So that equals a non-linear relation. Is not a straight line. Okay, let's look at this table. So let's look at the y values. How does it go from 21 to 15? It looks like it went down 6. So it got subtracted 6. What about from 15 to 9? Oh, I think it went down 6 again. And from 9 to 3, it went down 6. Okay, these values are called first differences. And they are all the same. If they're all the same, that equals a linear relation. And that's because, just like in our graph, we actually know this increase is actually the same. They're all the same. So 10 over 5 is equal to 2. 20 over 10 is equal to 2. 30 over 15 is also equal to 2. So they all are increasing by the same amount. So that's how you tell if something is linear or nonlinear. You check the first differences in the table, and in the graph, you see if it makes a straight line for linear and a not straight line for nonlinear.